In this video, we are going to discuss about voltage shunt negative feedback amplifier. So here it is called as shunt mixing. At the input you have shunt mixing, and at the output you have voltage sampling. Since we are using a shunt mixing, you have to employ current source at the input. So output you have a voltage. So I can write the gain. I can write gain. Gain is equal to V by I, because output you have voltage and the input you have current. So what is V by I? V by I is nothing but R. Okay, so let me write this one as Vm, and output I can write it as V0, and the input I can write it as II. Okay, so what is V0 now? V0 is equal to Rm into IA. So for this I am going to draw the circuit. So this is your Rm. So you have input as II. Sorry. Input as II, and output you have V0. So I have told you in the output, in the input we are using a shunt type. That is this is your beta. This is your feedback gain, and the input source is nothing but Is. And the output also I am using a voltage sampling. So since it is a voltage sampling, you have to connect it in shunt. Okay. So you have to draw the equivalent circuit for this one. Okay, so the equivalent circuit for this one is this is your Is, and this is your If, and you have a resistance Ri, followed by at the output side you have a V0 is equal to Rm into Ia. So this is your V0, the value is Rm into Ia. So Ia is a current that is flowing. Since I have used a voltage source, you have to connect R0 in series. Okay, so this is your RL. So this is your RL. Okay, so at this place I am going to take the V0. So what is beta? Beta is nothing but what is a beta? Beta output is IF. Okay, beta output is IF, and input is nothing but V0. So what is IF now? IF is equal to beta into V0. So for this circuit, you have to find the gain, input impedance and output impedance. Since we are employed both shunt connection at the input and output, my input impedance and output impedance with negative feedback Ri is reduced by the factor of 1 plus beta into Rm. So this is what I need to get. Okay, I about to get. And gain. So what is gain? Let me take negative feedback gain is equal to Rm divided by 1 plus beta into Rm. So this is what I supposed to get. Okay, now I can write on seeing this formula, I can write so these two are my input current. This is your input current, incoming current, and this two is your outgoing current. So I can write Is is equal to Ia plus If. Okay, so we know that If is equal to beta into V naught. So we substitute this one, Ia plus beta into V naught. So what is V naught? V naught is nothing but Rm into Ia. So you substitute, instead of V naught, you substitute Rm into Ia. So what is Ia? If we take common, beta into Rm. So this is your Is. So here I am going to divide the whole term by Vs, Vi. Okay. So if I divide the whole term by Vi, I will get 1 divided by Rif is equal to 1 divided by Ri into 1 plus beta Rm. So from this I can write Rif is equal to Ri divided by 1 plus beta Rm. So therefore my input impedance with feedback, with negative feedback, okay, with negative feedback decreased by the factor of 1 plus beta Rm. So this is about my input impedance. So next to find the gain. So to find the gain of negative feedback, consider this equation Is, this is your first equation, sorry A, and this equation you divide the whole term by V naught. So divide the whole on both sides, divide the equation by V naught. So if that is the case, Is by V naught is equal to Ia, you take it common, 1 plus beta Rm divided by V naught. So what is V naught by Ri? V naught by Ia is nothing but V naught by Rm. Here from this equation, Rm is equal to V naught by Ia, right? So you substitute this one. V naught by Ia is nothing but Rm. So V naught by Is is nothing but 1 divided by Rmf. Okay. So from this I can write Rmf is equal to Rm divided by 1 plus beta Rm. So this is about your gain with feedback. So you can see again the gain reduced by the factor of 1 plus beta m. Okay. So if I apply a negative feedback, the gain get reduced by the factor of 1 plus beta Rm. To find the output impedance, so we need to replace the equivalent circuit, because we must make the input source as 0. So here the input source is Is. So if Is is 0 means that should be open circuited. So my circuit, the equivalent circuit will look like this. And the output side, this is your I and this is your V now. And already connected RL is here. Okay, so now this is your V naught. So this resistance is R naught F, where R naught F is equal to V by I, and this one is nothing but R naught F bar, where R naught F bar is nothing but R naught F in parallel with RL. That is nothing but R naught F RL divided by R naught F plus RL. So first we know that IS is equal to IF plus IA. So here since IS is 0, this is your second equation, and this is your third equation. You substitute the value, I will get IA is equal to minus IF. And we know that beta, what is beta? Beta is nothing but IF divided by V. It is not V naught, because here I have only V. So what is the value of IF now? IF is equal to beta into V. So consider applying the mesh analysis at the input side, the output side. V is equal to I into R naught, I into R naught plus Rm into Ia. So this is your fourth equation, and this is your fifth equation, and this is your sixth equation. So you substitute 4 in 6. Substitute 4 in 6. If I substitute 4 in 6, I will get IR naught minus RM IF. Okay, that this is your V. And you substitute instead of IF, you substitute beta V. So this is nothing but IR naught minus RM beta V. Okay, so you take this RM beta V to the left hand side, you will get V plus Rm beta V is equal to I into R naught. So V I take common, and I divide the whole term by I will get R naught. So V by I is equal to R naught divided by 1 plus beta Rm. So what is V by I? V by I is nothing but R naught F. So you can see the output resistance also decreased by the factor of 1 plus beta Rm. So next we need to find the value of R naught F bar. R naught F bar is nothing but R naught F RL divided by R naught F plus RL. So you substitute this value. Instead of R naught, you substitute R naught divided by 1 plus beta Rm plus RL. Okay, so this I can write it like this, right? So you take this whole term here, you will get R naught plus RL into 1 plus beta Rm divided by 1 plus beta Rm. So this 1 plus beta Rm, 1 plus beta Rm get cancelled out, and you can write R naught F bar. R naught F bar is equal to R naught RL divided by R naught plus RL into 1 plus beta Rm. So this I can write it as R naught RL divided by R naught. You multiply, bring the RL inside, so you will get beta Rm. So now you take this you divide the whole term by R naught by RL. Okay, multiply and divide the whole term by R naught plus RL. You will get R naught RL divided by 1 plus R naught RL divided by R naught plus RL plus RL beta Rm divided by R naught plus RL. So I can take R naught bar is equal to R naught RL divided by R naught plus RL. So I can write this is R0 bar, and this is 1 plus beta Rm RL divided by R0 plus RL. Okay, so this I can write it as R0 bar by 1 plus beta capital Rm, where my capital Rm where capital Rm is nothing but Rm RL divided by R0 plus RL. So this is your final equation for R0 F bar. So I hope this video is useful for you. Thank you very much.